Hello everyone, I am Manoj. In a world where cyber threats are becoming increasingly sophisticated, it's no longer enough to just monitor the surface level of an application. We need to go deeper. My primary contribution to this framework was engineered to do just that. I developed a core OS scanning and threat detection engine. Because this is an OS level tool, we couldn't rely on simple if then simulation. We need a system that could achieve live interaction with the underlying kernel and system processes to identify real world malicious behavior as it happens. To achieve this, I engineered our scanning engine using Python psutil library. This script acts as a system extended sense. It continuously pulls the operating system to retrieve high frequency metrics like real time CPU utilization, memory allocation, and active network connections. But raw data is just noise without interpretation. That's why I built the detection logic in detector.py. This is the brain of our framework. It analyzes the system of metrics from the scanner and apply anomaly detection algorithms to flag a rogue process. For example, it can instantly pinpoint a process holding an unnatural amount of memory or detect unauthorized external connections that might indicate a backdoor or a malware payload trying to call home. To ensure our detection framework was truly robust, I also contributed to the simulation suite. I designed specific stress tests that intentionally trigger high resource usage and network spikes. This allows us to verify that our OS monitor successfully catches threats in real time, validating that the framework remains stable and responsive even under heavy system load without crashing the OS itself. By bridging the gap between raw kernel metrics and actionable security intelligence, we have built a tool that provides true visibility into the operating system's health. I am proud of how these modules work together to create a more resilient security postures. Thank you.
Hi, my name is Nipun and I was responsible for engineering the backend architecture and database integration for our security vulnerability detection framework. One of the major challenges we faced was that OS level polling generates a massive amount of data in a very short time. This can easily overwhelm a system if not handled efficiently. My goal was to design a lightweight high performance backend using Python that could ingest and process these metrics in real time without becoming a bottleneck. To solve this, I developed REST API endpoints that act as a bridge between the low-level OS scripts and the graphical dashboard. Whenever a potential threat is detected at the OS level, a backend immediately captures the alert, enriches it with action recovery suggestions, and broadcasts it to the dashboard for instant visibility. In addition, I focused on long-term security monitoring. I built a dedicated database module to securely store historical alerts and system health logs. The schema was carefully designed to allow fast and efficient query of past anomalies, which is crucial for forensic analysis and auditing. For example, if a system repeatedly shows unusual activity patterns, our framework can quickly retrieve historical data and help identify recurring vulnerabilities. Overall, my work ensures that the system is not only fast and responsive in real time, but also reliable and insightful for long term security analysis.
Hello, I am Taranjit Singh, and my core contribution was designing and implementing the interactive dashboard and front-end logic for our OSA monitor. A security framework is only good as its usability, while the backend and OS scanner are doing the heavy lifting. Security administrators need a way to visualize a system health instantly. I build a index.html and a style.css from the ground up to create a responsive, dark themed command center. My most significant technical contribution is in script.js. I engineered the client side logic to synchronously fetch live data from our backend APIs without refreshing the page as the OS scanner detects CPU spikes or unauthorized network activities. My JavaScript dynamically injected actionable alerts directly into the UI. I also focused heavily on user experience, ensuring that when a critical OS threat is detected, the dashboard provide immediately mitigation steps like process ID to kill so the user can restore their operating systems security within second.